May, June 2018, paper 3, variant 1. Question 1. Model trains. We have some model trains and we have two stopwatches. Okay, figure 1.1 shows the time on entering station A and time on entering station B. Can I find the time taken from entering A to entering B? Okay, can I find the time taken um, between them? Okay, how can I find the time taken? Simply, oh, actually, I'm sorry. He wants to find the time taken while entering station. Um, hmm, how can I find it? Yeah, to find the time, Shweb, it's quite easy. First of all, you need to convert the minutes to seconds. You need to convert the minutes hina and the minutes on this side to seconds. So hina you have 1 minute and 22 seconds. The minutes you need to multiply by 60. You need to multiply by 60. So you have 1 times 60, which is 60 seconds, plus 22. 60 plus 22 is 82 seconds. So هنا 2 times 60 is 120 plus 34, which is 154 seconds. صح? Okay, so to find the difference, what should you do? 154 minus 82 is 72. You need to find the time difference. You need to find the time difference, which would be 72 seconds. Okay, that's quite easy. Yeah, question 2. Um, Calculate the average speed. How can I find the average speed, Ishrab? Well, a faster train takes 54 seconds, okay? 54 seconds to travel from station A to station B. The distance between the stations is 120 meters. Average speed equals total distance over total time. Average speed equals total distance over total time. Total distance is 120 meters. The total time is 54 seconds. صح? So 120 divided by 54. Okay, yes, distance over time. Yes, برافو عليكم. Distance over time. يلا, this would be around 2.2. 2.2 meters per second. يلا, 2.2 meters per second. برافو عليكم. يلا. Moving on. Next question. Okay, we have a lot of answers in bro. I'm very proud of you. Yeah, determine the total distance traveled by the train on this part of the track. How can I find the total distance if I have a speed time graph? A speed time graph. How can you find the total distance covered by stating the area under the graph? Yes, bro. Area under the graph. طيب, how can I find this area? طيب, Mr. This is a trapezium and I forgot the area of the trapezium. I forgot how to find the area of the trapezium. Can I find the area of a triangle, a rectangle, and another triangle? Yes, you can. Yes, you can find the triangle. Oh, this is triangle. This is area 1. This is a rectangle, which is area 2. Okay, and then this is another triangle, area 3. You can do that if you'd like. If you'd like, it might take a little bit longer, okay, but if I can find the trapezium one shot, okay, that would be much faster. A trapezium, how can I find the area of the trapezium, which was b1 plus b2 over 2 times the height. B1 base 1 was the larger base, which was 14. So 14 plus B2, the smaller base. It started at this point and it ended at this point. يبقى from 4 to 10. From 4 to 10, which is 6. يبقى base 2 is 6. يبقى 14 plus 6 over 2 times the height. What is the height? The height is all the way up to this point, which is 3.5. صح? 3.5. So this is 20 over 210 times 3.5, 35 meters. 35 meters. Yes, good. برافو عليكم. يلا, let's go on. A student has a measuring cylinder and a balance. Describe an experiment to determine the density of the liquid. I have some liquid in this beaker. I need to find the density, also the density of the liquid. But density equals mass over volume. حلو. And definitely we will need to write this down. You need to write this equation down. 5 marks. You need to write a lot of steps. How can I find the density of liquid? First of all, you need to find the mass of the liquid. Good. Can I just put the liquid on a balance or a balance scale? لا. You can't just put it on the balance scale. You need to use another apparatus. You need to use, for example, a beaker, or to be more accurate, um, you need to use a measuring cylinder. Okay, someone's saying, would I calculate V1 minus V2 minus V1? Actually, in this question, لا. In this question, we won't find V2 minus V1. In this question, we will find M2 minus M1. And I'll tell you what's the difference. Okay, why will I use M2 minus M1? For this question, I need to find the mass of the liquid. I can't find the mass of the liquid alone. I need to find the mass of the liquid inside another measuring cylinder, or inside a beaker. So inside a measuring cylinder or a beaker. So first of all, I will find the mass. Okay, use a balance. Okay, to find the mass. Okay, of an empty measuring cylinder. An empty measuring cylinder. Measuring cylinder. حلو. An empty measuring cylinder. جميل. And then when we found the mass of the empty measuring cylinder, we will name it M1. We name it M1. And then add water, or add the liquid. Add some of the liquid, whatever, it doesn't really matter actually. Okay, add the liquid to the measuring cylinder. I'll just write it as MC, measuring cylinder. Okay, and find mass 2, and find the new mass. The new mass M2. صح. The mass of the liquid would be, calculate the mass of the liquid. Mass of the liquid is now equal to M2 minus M1. Let me zoom in. Okay, if you can't see. Using a balance to find the mass of the empty measuring cylinder, add the liquid to the measuring cylinder and find the new mass M2. The mass of the liquid is M2 minus M1. We'll call it a M. This is the mass of the liquid. طيب, how can I find the volume? Just take the reading from the cylinder. The volume of the water, the volume of the liquid is the reading, okay, from the cylinder. From the cylinder. So I just take the reading from the cylinder. Okay, and then we can say, well, density equals mass over volume. Okay, so this is V, the volume of the liquid, mass of the liquid. Someone's saying, why didn't we use the volume equation, V2 minus V1? Because we're not, okay, you're not required to find the volume of an irregular solid. Okay, if you have an irregular solid, a piece of stone, a piece of whatever, and you need to find the volume of this irregular shape, then you will submerge it into water using this displacement method and find V2 minus V1. That's if you want to find the volume of an irregular solid. But for this case, you don't want the volume of an irregular solid. You want the density of the liquid. This liquid could be water, it could be anything else. But how can I find the density? I need to find the mass and the volume. Yeah, but first of all, to find the volume, to find the mass, you need to find the mass of the empty cylinder first, and then the full cylinder, and then you can take the reading of the volume directly from the measuring cylinder, and then and then you can find the density. Density equals mass over volume. Yeah. So just the unit of the density, okay? The unit of the density used by the student. What is the unit of the density used by the student? In this case, we would say grams per centimeters cubed. Grams per centimeter cubed. Okay, يلا easy. طب Mr. Would it be wrong if I write kilograms per meter cubed? It wouldn't be wrong. Okay, it wouldn't be wrong. It wouldn't be wrong. Mr. More commonly used in measuring cylinders and small masses, we use a grams per centimeters cubed. طيب, I have a polythene block It floats in water. Why does the polythene block float in water? Because it's, yes, less dense than water. Because it is less dense than water. Density is lower. Yes. Okay, good. Hmm. حلو. Can I find the mass of the block? Can you find the mass of the block? I have the weight. How can you find the mass? Like mass weight equals mg. لا, you said multiply by 9.8. You won't multiply by 9.8. You'll actually divide by 9.8. You will divide by 9.8. So basically the mass is weight over g. 0.84 divided by 9.8. In this case, you will not multiply. Okay, the mass, يا شباب, is always less than the weight. Just think about it. The mass is always less than the weight. So 0.84 divided by 9.8 is 0.086. 0.86 kilograms. Okay, very straightforward. يلا بينا. Question 2. I have a couple of forces acting on a rocket. Calculate the resultant force on the rocket. How can you calculate the resultant force on the rocket? Okay, the upward forces minus the downward forces, the driving forces minus the resistive forces, whatever. صح? So, should I write it 9.8? Yes, write it 9.8 because we want to make sure that we do memorize the number 9.8, not 10. Okay? I know this is an old test, but again, use 9.8 to make sure into you have memorized the new number 9.8. Okay. Um, Calculate the resultant force on the rocket. 74.2 minus these two forces. Okay, minus these two forces. 43 plus 2.4, which is 28.8. Yes, okay. 28.8. And the resultant force would be upwards. Yes, thank you. The resultant force would be upwards. Okay. Um, Resultant force is basically we need to see which of these forces is stronger. Which of these forces is greater? So the greater force would be the upward force. That's why we minus 74.2 minus 43 and 2.4 to 28.8, and the direction would be upwards towards the greater force, towards the greater force. 74.2 is definitely greater than 43 plus 2.4, which is 45.4. Total downward forces are 45.4, upward forces 74. خلاص يبقى this wins. It's stronger, صح? Okay, it's stronger. It's as if you have two people pulling on a rope. Okay, the stronger person would pull the rope towards him or her. Okay, okay, yes, it's always the greater minus the smaller. Yes. Um, the resultant force on the object is zero. The resultant force on the object is zero for 10 seconds. We need to draw the uh, resultant force. We need to draw the direction and the magnitude of the speed of the ball after some time. Okay, after some time. What would the resultant be? Okay. Um, طيب, does anyone know? Or can anyone help me out? بص, if it's moving with a zero resultant force, yes, thank you, it would be the same. It would be the same. Why? Because zero resultant force means that it's moving with a constant speed in the same direction. So basically, I need to draw an arrow in this direction with a magnitude of 150 meters per second. That's it. That's it. Zero resultant force. Oh, he said zero. Resultant force is zero, meaning that it's moving with a constant speed in the same direction. Okay. Dلوقتي I have microscope. I'm observing a smoke cell. Describe and explain what the student sees when viewing the smoke particles through the microscope. Okay. When viewing the um, smoke particles. Yeah. Dirty, the smoke particle will start to move in a random zigzag motion. Why does it move in this random zigzag motion? Okay, we name it. It's the process is called what? It's called the Brownian motion. So it's called the Brownian motion. يعني كلمة Brownian motion, what does it mean? والله, the air molecules. You have to say that the air molecules move ازاي؟ يلا, air molecules move fast and random. صح? They move fast and random. But when they're moving fast and random, they collide. You have to say that they collide with the smoke particles, not the other way around. Please, if you say the other way around, if you say that the smoke particles collide with the air molecules, you would lose a mark. Okay, you would lose a mark. They're moving fast and random, colliding with the smoke particles, smoke particles, causing, oh, causing a random zigzag motion, causing a random zigzag motion. يلا. Okay, Brownian motion, air molecules move fast and random, colliding with the smoke particles, causing a random zigzag motion. Drops of water on a warm surface disappear after a short time. What is this process? It's called the evaporation. Yes, evaporation. Hmm. What is the explanation? What happens during evaporation? Most energetic molecules escape from the surface. That's it. Most energetic, okay, mole, molecules escape from the surface. You have to say that they escape from the surface, and you have to say that the most energetic molecules escape. Okay, not just any molecules, or not that the water evaporates. And I want to know, what does evaporating water mean? I need to know that in terms of molecules, the most energetic molecules escape from the surface. Okay. Hmm. Yeah. We have a process by which we can generate electricity. So someone saying leaving behind the least energetic molecules, you can say that, you can add that. But usually we add that line when we're talking about why does the water eventually become colder. Okay, why does the water eventually become colder? Yes, you say that the most energetic molecules escape from the surface, and then you continue saying leaving behind the least energetic molecules, causing the average temperature to decrease. Okay. Um. Um. Okay. يلا. يلا. دلوقتي, in a geothermal power station, the process of generating electricity includes 7 stages. We need to write them down. Yeah, let's write down these stages. Yeah, let's write down the stages. Someone's saying we start off with Q. Okay, we start off with Q. Hot underground rocks heat the cold water. Yes, that is correct. جميل. Okay, Q. وبعدين, after Q, you're saying S, hot water rises to the surface. Okay, good. S. And then cold water, hot water produces steam. Okay, correct. That's 100% correct. After S, what happens? Steam turns the turbine. Yes, P, definitely. And then R. Okay, the turbine, yes, spins the generator, and eventually the generator, okay, produces electricity. Good. يلا. The cost of electrical energy obtained from geothermal power stations is similar to the cost of electrical station or electrical energy obtained from wind turbines. Describe one advantage and one disadvantage of geothermal power station compared with the wind turbines. Of the geothermal compared to wind turbines. Why would geothermal power stations be a little better than wind turbines. One very obvious reason, one very obvious reason would be that the geothermal power stations are reliable. لا لا you said cheaper. لا احنا in this question he said ignore the cost. Oh, the cost is almost the same. Okay, the cost is almost the same. Um, One of the most important advantages of geothermal power stations compared to wind turbines is that geothermal power stations are reliable. They are reliable, steady output. Okay, reliable output. Okay, geothermal power stations. What about a disadvantage? Disadvantage. Okay, of a geothermal power station compared to the wind turbines. Geothermal power station compared to the okay, too much space. والله يعني if we talk about the actual space, actually the wind turbines take up much more space than the wind turbines. Someone saying better looking. لا, it doesn't actually have to do with how. Yes, you said they should be made in special places. Yes, that is correct. That is 100. There are only certain areas in which we can build these geothermal power stations. Okay, only available in certain areas. Okay, only available in certain areas. Someone saying are more renewable. لا, they're not more renewable. Okay, you can't say they're both renewable. Okay, you can say that geothermal power stations are reliable, and this is an advantage. This is an advantage. طيب. Um, يلا بينا. Okay, this is a nice question. I have a thermometer A and then a thermometer B. We had a container, okay, tank A, okay, which was connected to tank B. The water is passing from A to B. ماشي, the water as it passes from A to B, the sun heats up this water. صح? It heats up the water as it's moving from A to B. Determine the rise in temperature. حلو. Someone's saying 3. Yes, it is 3. So initially it was 23 and finally 26. So 26 minus 23, 3 degrees Celsius. Okay, piece of cake. Question 2 بقى. It's a really nice question. Part B يعني. The student wants to increase the thermal energy absorbed by the water in the pipe. He wants to increase the amount of energy absorbed. Suggest 3 improvements that he can make to increase the thermal energy absorbed. يعني this, we have a pipe. صح? This pipe is in the sun, okay? And I want to improve, okay? I want the water to heat up more. You want the water to heat up more. Okay, so you're saying it ماشي حلو. I guess لا, use a glass pipe. This would be wrong. Actually, using a glass pipe would be wrong. Okay, you're saying paint it black. Yes, that is correct. Instead of using a white pipe, yes, we can use a black pipe. برافو عليك. You paint it black. Yeah, this is number 1. يلا, paint it black. جميل. برافو عليكم. You said instead of using a plastic, برافو عليكم, huh? Bravo. Instead of using a plastic pipe, use a metal pipe. Why? Because metals are better conductors of heat. Yes. eh, برافو عليكم, huh? Metal pipe. Metal, huh? Pipe instead of a plastic pipe. And the third one is actually quite يعني easy برضه. The third one هو ايه? Instead of having a very short pipe, yes, increase the length of the pipe. Increase the length of the pipe. And that's it. Okay? A longer pipe. A longer pipe. خلاص, يبقى use a much longer pipe. Okay? تمام. Use a much longer pipe. يلا بينا. طيب. Describe how the thermal energy is transferred from the sun to the water inside. Mr. Why do we use a longer pipe? So that it spends more time in the sun, so that it can absorb as much energy as possible in the sun. Okay, if the water keeps on moving for a longer distance on the sun, it will get hotter eventually. Okay. um يلا جميل. um يلا بينا. Describe how thermal energy is transferred from the sun. يلا radiation. Yes, thank you. Radiation in the space. يبقى as the energy transfers is transferred in the space, it comes through infrared radiation, and then inside the pipe, inside the pipe would be through conduction. صح. يبقى radiation in space, and then I have to say radiation, or to be more accurate, infrared radiation. صح. Radiation in space, and then conduction in the pipe. um اوكي يلا بينا. اوكي يلا. Can I write down the missing colors? I guess we can. Red, orange, هنا yellow, and then blue. Yes, blue. Indicate the direction of increasing wavelength. Increasing wavelength. Okay. Um, the longest wavelength would be the red. Longest wavelength would be the red. يلا. Longest wavelength هيبقى ايه the red. يبقى you have to draw the arrow to the right. يلا. um يلا بينا. hmm. I have a glass prism array of red light. Ray of red light. Draw the path of the ray as it travels through the glass prism and enters, okay, and enters the air. As it goes through the glass prism, it is refracted a little, صح, downwards, and then as it moves away, it also is refracted a little كده. Okay, so we have two refractions as it enters the ray, as it enters the prism, and as it exits the prism. State the term used, okay, as it enters and leaves the prism. No, not dispersion. Not dispersion. In this case, refraction. In this case, not dispersion, you will say refraction. Do I need to draw to the ruler? Yes, you do need to draw to the ruler. Okay, this is refraction, not dispersion. Dispersion if the initial light was white light, and then he drew the seven colors. Okay, this would be the dispersion. But if you have red light, it will enter as red light and exit as red light. It wouldn't disperse into more colors. Okay, it wouldn't. Okay, good. Yeah, there's a question. What is the color of infrared? Actually, there is no color for the infrared. You cannot see the infrared. We as humans cannot see infrared. Why? Because we humans can only see the visible light. We can see the frequencies of the visible light, and that's it. We cannot see any other colors. Okay? As humans, we cannot see any other colors. Okay. State the name of the equipment for measuring the distance. ايه ده? Yes, the distance. Measuring tape. Measuring tape. State how the sound forms an echo. How this sound forms an echo. يلا. Very easy. It reflects. Yes, thank you. It reflects off the wall. Reflects off the wall. Yes, it hits the wall and reflects. Yes, thank you. Off the wall. The student hits her drum repeatedly once per second. Okay. Uh, she, she hits the drum repeatedly once per second. She walks away. Okay. She hears the sound again. She hears out, listens for the echo. When the student is 170 meters exactly away, she hears the echo. Okay, from one beat. Okay. At the same time, جميل. Use this information to determine the speed of sound. State the unit. Okay. State the unit. How can I find the speed? How can you find the speed of the echo? والله echo احنا we said it's a reflection, meaning that it will hit the wall and come back. صح? Hit the wall and come back. لا, time is given. Mr. Time is not. لا, it is given. Where is it? Once per second. Once per second. So the time is 1 second. Time is 1 second. Um, Echo equals 2D. Yes, because the sound travels all the way to the wall and then comes back. 2D over T. 2D over T. يعني 2 times 170 over the time, which is 1 second. Which is 1 second. يعني 340. And that's it. Okay. 340 meters per second. Okay. يلا بينا. Mm, 1 second. Okay. 340. Okay, I'm just 40 meters per second. طيب. On figure 9.1, add the names of the missing. يلا, what are the missing radiations in this case? هنا it's quite easy. Rami looks great. صح? Rami looks great. So radio, and then هنا B would be microwave. صح? B would be microwave. Yeah, microwaves. And then Rami looks, so this is X-rays. صح? X-rays. يبقى on figure we wrote down the names and then indicate the radiation that has the lowest frequency. Lowest frequency would be radio because they have the longest wavelength. States to safety precautions. State two safety precautions. Um, Two safety precautions would be, yes, increase the distance. Yes, thank you. Increase the distance, decrease the time of exposure, use a protective barrier. صح? Decrease the time of exposure. Time of exposure, use a protective barrier, use don't hold it with your hands. That's not actually the precaution, but you can use long tongs, as we say. صح? Use a protective barrier. مم. طيب جميل. يلا بينا. يلا. Label the fixed resistor by writing R. يلا, فين fixed resistor? This is quite easy. The fixed resistor is the one above the voltmeter. صح? The one above the voltmeter. يلا. R. Two components to measure two electrical quantities. What are these two components, Mr. Quantity? This is the ammeter. صح? This is the ammeter. And the unit of the ammeter would be the volts. صح? يبقى أول واحدة الأميتر. What is the quantity? It is the thing you're measuring. Okay. طب I'm measuring current. What is the thing I'm measuring? This is the current. So the quantity is the, yes, current. طيب. And the unit is amps or A. Unit and quantity is current. And the units is A or amps or amperes. صح? Um, quantity, the second quantity is potential difference. Okay, potential difference or EMF or whatever. And the unit is V or volts. V or volts. Why is the fixed resistor always above the voltmeter? لا, it's only in this question. Okay, the voltmeter could be on any other component. For this question, okay, it's above the component. Why not voltage as the quantity? To be more accurate, the better quantity would be to write down the potential difference or the electromotive force. Okay. Um, I'm saying, it would be better to write down potential difference or electromotive force. This would be much better as the quantity for this question. What's the difference between EMF and PD? We said it before. Potential difference is the voltage of a device. The EMF is the voltage of the power supply of the battery. It's a difference in voltage. Um, Quantity is current. Yes, the quantity again. The component الاميتر. It measures what? What does it measure? It measures the current. What is the unit of current? Amperes. بس. الفولتميتر it measures the potential difference. What is the unit of the potential difference? The volts. طيب. Student uses the circuit, okay, and he has the wire, how the resistance of the wire is related to the length and the diameter. Okay. How طب I have another question. Is the resistor always in parallel? No, it's not that the resistor is always in parallel. It's that the voltmeter is always in parallel. So if you ever want to measure the voltage, the potential difference, the EMF, okay, of any device, the voltmeter needs to be in parallel with whatever device you have. Okay. Length. Yeah, yes. As the length increases, okay, as length increases, what happens to resistance? Resistance increases as well. So we call this a directly proportional relationship. So directly proportional relationship. Diameter, okay, as diameter as the diameter increases, resistance decreases, which means that this is an inversely proportional relationship. Inversely proportional. يبقى length is directly proportional, diameter is inversely proportional. Okay. جميل. Yeah, draw a cell and a switch in series, okay, to complete the circuit. How can I complete the circuit? How can I draw the cell and the how can we draw them يا شباب this way in series? Yeah, you have battery and the switch which are in series. صح? A student sprinkles iron fillings onto the card and closes the switch. There is a current in the conductor. Describe the pattern of the magnetic field seen. Describe the pattern of the magnetic field seen. What is the pattern of this magnetic field? If I have the iron fillings around the wire, they will create circles. So it would be a circular pattern around the wire. But they are circles. We have a circles around the wire. Yeah, they are circles. Yes, they attract, forming circles around the wire. um, they will form the magnetic field around the wire would be circular. The magnetic field around the wire would be circular. As we said, it could be clockwise or anti-clockwise using the the right hand rule grip. The right hand rule grip. Okay, the thumb current magnetic field around the wire. The student reverses the direction of the current in the conductor. State the effect, if any, on the pattern he sees. If he reverses the direction of the current, what happens? You say, well, the magnetic field should be reversed. The magnetic field, it should be reversed. It should be in the opposite direction. But for this question, for this question, can you actually can you actually see the direction of the iron fillings? Are the iron fillings actually moving around the wire? No, they're not moving around the wire. They form these circles around the wire, and that's it. They form the circles around the wire. You can't actually see the arrows clockwise or anti-clockwise. You can't see them. So what happens is nothing actually happens. Nothing happens. ليه؟ خلاص they are circular. They are circular around the wire. You cannot see the direction clockwise or anti-clockwise. It will remain as it is. يبقى nothing changes. Okay? Nothing happens. Okay? Nothing changes. Nothing else. Describe an experiment to show that the force acts on the current carrying conductor in a magnetic field. بصوا a force acts on a current carrying conductor in a magnetic field. يبقى this is a simple DC motor. You need to draw a simple DC motor. What is a simple DC motor? It's a wire between two magnets connected to a battery. Okay, the wire will move upwards or downwards. I don't care. This is a magnet. I have the magnet, North Pole, and the South Pole, which is, and we have a wire connected to a battery. صح? Connected to a battery. There is a current in the wire. Yes, there is a current in the wire. Let me draw the current in the wire. Current is moving in this direction. صح, it's moving in this direction. طب is there a magnetic field? Definitely there's a magnetic field from North Pole from North Pole to the South Pole. صح? يبقى we have magnetic field, we have current. Include a diagram. Yes, you have to include a diagram. Okay, you have when he says include a diagram, you must include a diagram. Okay, if you don't draw, you will lose a mark. Okay, in this question, if he says you may draw a diagram, then you don't have to draw. But for this question, you have to draw a diagram. You have a current carrying conductor. A current carrying conductor means that you have a wire which has a current in it. You have a wire with a current passing through this wire. How does the current pass through the wire? By connecting it to a battery. When you connect this wire to a battery, the current passes through the magnetic field. Now you have two magnetic fields. Where are these two magnetic fields? If you think about it, where are these two magnetic fields? You have a magnetic field around the wire. Okay, let me use a different color. You have a magnetic field around the wire. Around the wire, it's circular around the wire. And you have another magnetic field which is from the north pole to the south pole. So if these two magnetic fields intersect, meaning I have a north pole, for example, next to another north pole, it will repel. A south pole next to another south pole, it will repel. A north pole next to a south pole, it will attract. So definitely there will be a force. And this is the basic operation of a DC motor. Now we have two magnetic fields that intersect, causing a force. Okay, I have this battery in front of me, and the magnet. Okay, magnetic field lines and the wire. What happens to the wire? Okay, the wire will move. That's it. That's it. And والله الwire moves due to the current passing through it. الwire moves due to the current, due to the current passing through it. You don't need to go into too much details with a question like this one. Okay, not too much details at all. Hmm. يلا بينا. Okay, yeah, that's it. Wire will move either upwards or downwards. I don't care about. Okay, 4 marks because You have to draw a very good, not an excellent diagram, but a rather good diagram. Okay, you have to draw the battery. You have to draw the magnetic field, the wire. You have to draw the current in the wire. That's it. You have to draw a lot of things. That's why you need to draw on this question. Okay, you need to draw this question. ماشي. Hmm. يلا. Radioactive decay may include the emission of alpha, beta, or gamma. From the list, state the type of radiation which has the greatest ionizing effect. The greatest ionizing effect would be greatest ionizing alpha. طبعا alpha عشان it is positively charged +2 يبقى alpha. From the list, state the type of radiation which has the lowest penetration effect. Lowest penetration effect is the برضو alpha. Alpha. um يلا خلاص we're almost done. Type of radiation. Now we have a roller, we have a thin aluminum foil which is passing. In the factory, rollers press aluminum metal to make thin foil sheets. ماشي, an automatic system for controlling the thickness. بصوا, the thickness of the foil. Okay, it uses some sort of radioactive source. What is the type of radiation that should be used in this question, in this experiment? What is the type of radiation that should be used? We have a thin aluminum foil. Thin aluminum foil. طب بص, let's think about it. Let's think about it. Would the alpha pass through it? Would the alpha pass from this source to the detector? No. Why? Because the alpha penetration ability بتاعها, it's very very weak. So alpha definitely will not pass. It won't pass. طيب, beta, احنا we know that the beta is stopped by a thick, not a thin, by a thick aluminum foil. A thick sheet of aluminum. Beta is stopped by a thick sheet of aluminum. So can the beta pass through this thin aluminum foil? Yes, it can. Beta, it can pass through this thin aluminum foil. It will pass. Okay, طيب, okay, I might use beta. طب can I use gamma? Can I use gamma radiation? No, definitely not. Why? Because the gamma radiation will pass through whether it is thick or thin. Gamma radiation would pass through whether it is thick or thin. It doesn't actually matter. So the gamma radiation wouldn't help that much. It would pass the top. And this question for this experiment, for you to understand what's happening, and do you want the thin aluminum foil to pass through with a certain thickness, with a certain thickness. So the beta can pass through if it is quite thin. If it happens for some reason and the aluminum foil is a bit thicker, then the beta radiation won't be able to pass. And that's why in this question we will use the beta radiation. Again, the explanation, how can I explain this? Okay, it would be affected. It would pass through the thin aluminum foil, but it would not pass through a thick aluminum foil. Yeah, that's all you need to say. El beta would pass through a thin aluminum foil, a thin aluminum aluminum foil, but not through a thick aluminum foil, a thick sheet. طيب, why don't we use gamma? دلوقتي I want you to think about it. If you have a thin aluminum foil, the beta will pass and the radiation will detect. وتمام, the process will go on. If it is a bit thicker, the beta will not pass. So the radiation detector will not detect that there is any sort of radiation. So the counter would stop. Okay, the counter would stop, indicating that there is a fault, something's faulty. Okay, the sheets are a bit too thick. The sheets would be a bit too thick, so you need to stop immediately. You need to stop immediately. يبقى دلوقتي what we need to use a beta, okay, source, not a gamma source. Why? Because the gamma source would pass through even if it's much thicker. The gamma would pass through even if it's a bit thicker. لا, احنا we need it to stop. You want the foil to stop. You want this operation to stop if the you want the operation to stop if the aluminum foil is a bit thicker. بس. Okay, يلا. The aluminum foil passing through the radiation is too thin. Okay, is too thin. Describe how this fault affects the reading on the counter. Okay, if the radiation or if the aluminum foil is a bit too thin, okay, then more beta will be able to pass through. More beta will be able to pass through. So this would mean that the counter, okay, the counter now would give a much higher reading. Now, that's the thing with the gamma. That's the same thing with the gamma. Counter, okay, counter will give a much higher reading, a much higher reading It's for example, if you use gamma radiation, the counter will keep on reading for very high numbers. Why? Because all of the radiation, okay, all of the gamma radiation will be passing through, so the counter will keep on increasing and increasing. It would be wrong. It would be wrong. Okay. The question wants to know if the foil is thick or thin. Yes, he wants to know if the foil sheet passing through is مثلا 1 millimeter. If it's 1 millimeter, that's okay. If it increases to 2 millimeters, that wouldn't be okay. The counter, the radiation, the amount of radiation that's passing would decrease, and the counter would give a wrong number or whatever, and we would be able to stop the um, process. Suggest how the fault in BII is corrected. If the aluminum foil is too thin, if the aluminum foil is too thin, how can I correct this fault? If I look at this operation, if you look at the figure, these rollers, if they are too close together, if they are very close together, what happens? The thin aluminum foil would be very thinner, much thinner. أنا لا دلوقتي it would be wrong, and I want it to be a bit thicker, just slightly thicker. What should you do to these rollers? Just pull them away. Okay, just increase the distance between these rollers. That's it. That's it. You need to move them apart. بس كده. يبقى increase the forces, increase the distance between the rollers. بس increase, okay, the distance between the rollers. Huh. The source uses strontium 90, and nucleus of strontium can be described as 9038 SR. State the number of protons. I guess this is very easy, and I know we can all answer this question. How many protons does it have? How many protons does it have? 38 protons. Yes, bravo عليكم.